Finding areas of trapezoids. Determine the area of the trapezoid. Now there is a formula for finding the area of a trapezoid. If you know it, you can use it. I'm just going to break it up into a triangle and a rectangle. So here I have a rectangle that is 3 by 6. So a 3 by 6 has an area of 18. This whole side length was 9, but this red portion was 6. So that leaves me with 3 as my base here, and it has a height of 3. So 3 times 3 is 9, but it's a triangle, so we have to divide it by 2. 9 divided by 2 is 4.5. And then we add those together to get the full area of the trapezoid. 18 plus 4.5 is 22.5. Don't forget to include your units for area. We know from earlier grades that to find the volume of a rectangular prism, you would do the length times the width times the height. Well, the length and width is just the area of the base. So another way that we could write this is the base area times the height. We're also going to learn more about triangular prisms today. So if we separate the rectangular prism into triangular prisms, what might be a formula we could use for the volume here? So you can see that they've cut them into different sections, showing different ways that we could cut the rectangular prism into 2 parts. If we look at one level of that, here we have the base, and we're cutting the base in half. So the shape of this would be half of the base area, or half of the base area of a rectangle, times the height. But this half of the base area of a rectangle is just the formula for the triangle. So if we just think of it as the formula for a triangle's base, and then times it by the height of the prism, that would work in this case as well. So we're swapping out the base area of a rectangle with the base area from a triangle. This right triangular prism was formed by slicing a right rectangular prism in half. Determine the volume of the prism. So first we're going to start with the base area, which is the shape of a triangle. So we have the triangle, which is a 3 by 4. And since it's a triangle, we divide by 2. 3 times 4 is 12. 12 divided by 2 is 6. And the height of the prism is 6. So the volume is the base area times the height, which is 6 times 6, or 36 units cubed. Remember, the volume is 3-dimensional, so it gets units to the 3rd power. Find the volume of this triangular prism. Remember, we discussed in earlier lessons that the triangle would go on the bottom, and this triangle would go up to the top. So in reality, the height of the prism is going to be this 16 measurement. And then we also need the base area of the triangle. Well, the triangle is a base of 12 and a height of 8. And triangles get divided by 2. So if we did 12 times 8 divided by 2, that would give us 48. as our base area, and 16 is the height of the prism. So this has a volume of 48, the base area, times the height. So 48 times 16. And that comes out to 768. The units are centimeters, and volume is to the third power. Jonah's work to find the volume of this solid is shown. All measurements are in feet. So let's break it down. He has 5 times 4. That is 5 times 4 for this rectangular piece. And that he shows is the base area. And he's saying the height is 12. Keep in mind we need to put the odd shapes on the top and the bottom. So you'll have to kind of tilt it in your brain to stand it upright. Well, that 5 times 4 comes out to 20. 20 times 12 is 240. That is just the rectangular prism section. Then over here, he's separately found the area of the triangular prism. So you can see if this was a distance of 5, this would have to be a distance of 3 to get the total of 8. So it is a base of 3 and 4 for the triangle. And triangles are cut in half. 3 times 4 is 12. Half of 12 is 6. And the height of the triangular prism is 12. 6 times 12 is 72. So if we want the total volume of this whole prism, we need to add the rectangular piece and the triangular piece together, which gave him 312 cubic feet. Explain how Jonas found the volume of the solid. So he found the volume of the rectangular prism and triangular prism. Added them together. Nora says this is still a prism. Can we just use the volume equals the base area times height to find the volume? How would you respond to Nora? I would say yes, we would need to find the volume, or the base area of the trapezoid, and then multiply. Find the volume of the prism by using Nora's strategy. We have a trapezoid with these dimensions. So we're going to break it up into a rectangle, which has a 5 by 4, and a triangle, which we said 5 plus 3 makes 8. The height of that triangle is 4, and then triangles get split in half. So if we did this, that piece would be 20 for the rectangle. 3 times 4 is 12. 12 divided by 2 is 6. So it has a base area of 26. And then the height of the whole prism was 12. So the volume will be 26, the base area, times the height, which was 12. It should come out to the same value as Jonas found when we multiply. We get 312, which was the same as Jonas's calculations. Find the volume of this right trapezoidal prism. So the base is going to be the trapezoid, and then the height is going to go this direction. Remember, we want the trapezoid to be on the bottom and up on the top. So for the trapezoid shape, we have a dimension of 2 going across and a height of 2.3. That's this rectangular piece of the trapezoid. And we have this triangular piece. Well, that is a height on the triangle of 2.3. And this base section, if this part is 2, to get a total distance of 2.9, this section here would be 0.9. And since it's a triangle, we have to divide it into 2 parts. 2 times 2.3 would be 4.6. 2.3 times 0.9 divided by 2 is 1.035, giving us a total base area of 5.635. And then the height of the prism is 1. The volume is found by the base area multiplied by the height. So we're going to multiply 5.635 by 1, which is a volume of 5.635 meters to the 3rd power. Find the volume of the right regular pentagonal prism. The line segment that has a length of 9 units begins at the center of the pentagon. Remember, we've been splitting this up into triangles. A pentagon will be split into 1, 2, 3, 4, 5 triangles. The triangle has a base of 13.1 and a height of 9, and triangles get split into 2 parts, but because it's a pentagon, we need 5 of those triangles. So 13.1 times 9 divided by 2 is 58.95, and then we'll multiply that by 5 to get the total base area, which is 294.75. And then the height of the prism is 18. To calculate the volume, we do the base area times the height. And that gives us a volume of 5,305.5 units cubed. Find the volume of the water that Eve's right regular hexagonal prism fish tank can hold. The line segment that has a length of 9.1 inches begins at the center of the hexagon and ends at one side of the hexagon. The base hexagon is going to be broken into 6 triangles. The triangles have a base of 10.5, a height of 9.1, and since it's a triangle, it gets divided by 2. We'll multiply 10.5 by 9.1, then divide that by 2. which is 47.775, and then multiply that by 6 because there are 6 of those triangles that form the hexagon. There's 1, 2, 3, 4, 5, 6. And the height of the prism is 24. So the volume is going to be found by multiplying the base area by the height. And that is 6,879.6 inches to the third power. The volume of this right rectangular prism is 48 cubic feet. Determine its height. So again, volume is found with the base area times the height. In this case, the volume is 48. So we're replacing the letter V in our formula with the number 48. The base area is based on the bottom of the prism. It's a rectangle, so we would do 8 times 3, which is 24. So this turns into the equation 48 equals 24h. To solve it for h, we would need to divide both sides by 24. That leaves us with h, and 48 divided by 24 is 2. So the height is 2 feet. The volume of this right regular pentagonal prism is 442 cubic millimeters. The line segment that has a length of 3.4 millimeters begins at the center of the pentagon and ends at one side of the pentagon. Find the height of this prism. Well, let's start by finding the base area. This distance is 4, and since it's a regular pentagon, all the sides of the pentagon are 4. The pentagon has 5 triangles that make up the base. 1, 2, 3, 4, and 5. We have a 4 by 3.4 triangle, and triangles get divided by 2. So do 4 times 3.4 and divide that by 2, which is 6.8, and multiply by 5 to get the whole pentagon. We don't know the height, that's what we're trying to find. Our formula uses base area and height. We know the base area is 34. And we know the volume is 442. So to solve for the height, we can divide both sides by 34. 34 divided by 34 is 1, so we have 1h. And 442 divided by 34 is 13. Which means that the height of the prism is 13 millimeters. A height does not get any units squared or units cubed, it's just plain units. That will do it for lesson 24. Again, check back for more videos on my YouTube channel.